Augmented Generation for Improved Prompt-Based Requirement Engineering. And we are a group of three, myself, Akhil Reddy, and Meng Cheng Lee. So here is the today's agenda of our presentation. We're gonna start with introduction and then we will proceed with how LLMs are currently working on requirement engineering, and then we will showcase that how retrieval augmented generation can change our RE methodology. So let me start by setting the foundation for this work. So requirement engineering is fundamentally a text-driven discipline. All core electives eliciting requirements, classifying them, validating consistency, and maintaining traceability all depend on integrating large volume of natural language processing. Recently, large language models like GPT-4, Gemini have been introduced into this workforce because they can automate tasks such as restructuring or analyzing requirements with impressive fluency. But despite of this potential, prompt-based use of LLMs comes with serious limitations. In our research, we repeatedly observe hallucination, a lack of project-specific context, strict context window constraint, outdated knowledge, and almost no traceability. This is where retrieval augmented generation becomes valuable. RAG ground the LLM using actual project artifacts retrieved from document repositories. By injecting retrieval evidence into one prompt, RAG reduces hallucination, provides domain context, bypass context window limit, and restore traceability. So the motivation behind this work is simple: to improve the reliability and trustworthiness of LLM-based requirement engineering through retrieval augmented methods.
And now the problem statement limitation of prompt-based RE. Large language models are useful in requirements engineering, but prompt-based methods still have many issues. First, LLMs can hallucinate the meanings. They may generate the requirements or trace links that look correct, but they are actually wrong. The second one is they often lack project specification context, so they are missing important domain terms and standards. And the third one is LLMs have a limited context window, meaning meaning they cannot process large documents at once. And the fourth one is their knowledge can be outdated because models cannot automatically learn new updates or recent documents. And finally, there is a pure traceability. Since outputs usually do not link back to the original source, making verification is so difficult. The next slide is uh, retrieval argument retrieval argument generation. RAG overview. RAG helps to solve these problems by combining LLMs with a document retrieval system. Instead of depending on only on RAG, uh, instead of depending only on model memory, RAG brings in relevant project documents during this generation process. Here, how the RAG works. First, the document corpus. All project documents like requirements and standards are stored in a searchable database. And the second one is retrieval. When the users asking say questions, the system finds out the most relevant document chunks. And the third one is augmentation. These retirement documents are added to the LLM's prompt to help it generate accurate answers. And the next slide is the research gap and contributions. There are still limited research on using RAG in requirement engineering, even though it works well in other NLP tasks. Also, prompt-based RE is not reliable due to limitation methods earlier. Our contributions includes a survey existing prompt-based RE and RAG techniques, a framework showing how RAG can solve RE challenges, a taxonomically of 4 RAG integration strategies for RE, a reference architecture of RAG enhanced RE system, suggestions for further research directions. That's all.
Okay, and now I will introduce the role of large language models and prompt engineering in requirements engineering, which is RE. And in recent years, the LLMs such as GPT-4 have been increasingly used to automate RE tasks. These tasks include elicitation, classification, extraction, and ambiguity detection, and early validation. And because RE is a very text-heavy activity, LLMs naturally fit into the workflow. Prompt engineering allows us to guide the model's behavior without retraining it, simply by writing clear instructions. And there are three common techniques include. First is zero-shot prompting, where we directly ask the model to perform a task. And the second is few-shot prompting, where we provide example to stabilize its output. And the third, last one is chain of thought prompting, where we encourage step-by-step reasoning. However, even with strong prompt engineering, there are 5 major limitations in prompt-based RE. And it's hallucination. LLMs create requirements or trace links and that are not in the project. And the second is the lack of project-specific context. The model does not know organizational standards or domain items. And the third is the limited context window. It cannot process thousands of requirements at once. And outdated knowledge, it cannot automatically learn new project updates. And the last one is traceability. Output have no links back to source documents. This weakness shows that prompt alone are not enough, and they motivate the use of retrieval-augmented generation, or RAG. Next slide.
Recent So here is the solution and advances in prompt-based research engineering. So in recent years, we have seen a meaningful improvements in how LLMs are applied to requirement engineering through better prompt design. So precise prompts, especially techniques like chain of thought prompting and irretrievable refinement, help guide the model forward more accurate reasoning and reduce obvious hallucination. We also see gains when prompts incorporate domain knowledge. Using prompt specific examples of terminology direct inside the prompt significantly improves performance on specialized RE tasks, especially where generic LLM training data falls short. But the most impactful advancement is the introduction of retrieval augmented generation. By retrieving relevant project documents and injecting them into the prompt, RAG brings real evidence into the model's reasoning process. This improves accuracy, context awareness, and also enables traceability. Together, these techniques reduce manual cleanup, support reusable prompt patterns, and make LLMs more effective in complex in complex iterative RE workflows. So here I'm going to show that how introducing RAG to RE limitations so that we can solve this main 5 problems on RE. So one of the core contributions of this work is showing exactly how retrieval augmented generation addresses the 5 major limitations of prompt-based requirement engineering. So first of all, RAG reduces hallucination by grounding the model in real requirement documents. So the output is evidence-based rather than invaded. It solves the lack of project context by retrieving domain terms, standards, and historical requirements, giving the model the context it normally lacks. It's also bypass context window limits by retrieving only the small relevant chunks needed for the tasks rather than forcing the LLM to read entire specification. RAG keeps knowledge fresh because retrieval can incorporate newly added documents instantly without retraining the model. And finally, it restores traceability by it restores traceability by attaching outputs to the source documents that inform them. So the key impact here is the RAG directly mitigates all major prompt-based requirement weaknesses, making automation more reliable, transparent, and grounded in the real project data. So here RAG solution for prompt-based RE limitations. So this table summarizes how retrieval-augmented generation systematically fixes the weaknesses we see in prompt-based requirement engineering. For hallucination, RAG grounds the LLM in actual requirement documents, ensuring outputs are tied to real evidence, and for lack of prompt context, it retrieves glossaries, terminology, and standards that the RAG would otherwise not know. With context window limitations, RAG retrieves only the relevant slices of information so the model isn't overwhelmed by the full specifications. Outdated training data is solved through live corpus retrieval, meaning the document repositories can be updated at any time without touching the model itself. And finally, poor traceability is addressed by explicit source attribution, where outputs reference the documents that influence the reasoning. So each failure mode of prompt-based RE has a clear mitigation path using RAG. So here is the taxonomy for RAG integration strategies. So the first is document grounded generation, where RAG retrieves relevant requirement templates or standards so that newly generated requirements are accurate, consistent, as well as aligned with the prior project artifacts. Second is context aware analysis, which supports tasks like classification, ambiguity detection by retrieving similar past requirements or project glossaries. The model gains the context it normally lacks. Third, traceable validation, user retrieval to check consistency and detect conflicts by bringing in related constraints or dependencies. The ensure validation is evidence-backed rather than heuristic. And finally, evidence-based refinement, where watch or low quality requirements are improved using actual feedback, test cases, or reviewed comments. Together, these four strategies show how RAG can be applied across the entire RE workflow, not just a simple task. Now, I request Lee to let us understand the architecture of RAG.
Okay, I will walk through our solution workflow diagram, which shows how RAG enhances prompt-based requirements engineering. And this workflow contains 5 major stages. I will explain them in order. Okay, next slide. Next one. And the first one is user input. The process begins when the requirements engineer or an automated tool submits a prompt. This may be a task like classify these requirements, check if two requirements are inconsistent, or refine these ambiguous requirements. This user input defines what the system needs to do next and triggers the workflow. And the second one, next slide, is project artifact repository. Next slide. And the system next system accesses a document repository. This repository stores all relevant project artifacts, including requirements, documents, domain standards, design decisions, traceability metrics, and historical requirements. This document provides the authoritative evidence needed for accurate RE tasks. And if the LLM only relies on its own training data, it may hallucinate. But with RAG, the system always refers to a real project documents. And the third one, next slide, is the semantic retriever and augmented prompt generator. This is the core part of a workflow. First, the semantic retriever searches a vector database to find the most relevant document chunks for the user's query. It uses embedding similarity to identify project specify specific terms, standards, or related requirements. Then the augmented prompt generator combines the original user query and the retrieve evidence. This creates the augmented prompts that give the LLM the exact project context it needs. This step is crucial because it reduces the hallucination as domain knowledge and keeps the LLM grounded in the latest documents. And the fourth one, next slide, is LLM and RE task generation. And with this enriched prompt, the LLM performs the actual RE task. For example, it can classify a requirement as functional or non-functional. It can also detect conflicts or inconsistencies. It can rewrite ambiguous requirements. It can generate missing requirements based on examples. Because the model now sees the relevant project context, its output becomes more accurate, more consistent, and more project aware. And the last one, next slide, is traceability, source linking, and feedback loop. And finally, the system links every part of the output back to the source documents. This creates full traceability, which is essential in regulated domains. And the feedback loop always allows engineers to review, refine, and correct outputs. The system can then use these refinements to improve future retrieval and generation. Overall, this workflow shows how RAG transforms the prompt-based requirement engineering, based on RE, from guessing model into a grounded evidence driving system. And I think this is the central idea of our paper solution. And next slide, I will introduce. I will also let's take a look at the impact of RAG on requirements engineering and how we can measure it. Next slide. And RAG improves the RE performance by targeting the 5 major limitations. And the first one is reduces hallucination because outputs are grounded in retrieved evidence, and it adds project context by retrieving domain items, standards, and the historic requirements. It bypass context window limits by retrieving only the most relevant chunks. And it also keeps the knowledge fresh, as the retrieval always uses the latest documents. And finally, it improves traceability since outputs include the citation to source documents. To measure the impact of RAG in RE, we can also use several metrics. The first one is accurate metrics, correctness in classification task, precision, and recall for traceability inks. And the second, hallucination reduction, which is counting how many generated items are unsported for fabricated. And studies show RAG can reduce hallucination by 30 to 40% in knowledge intensive task. And third is context relevance, evaluating how well retrieved documents match the user query. And the fourth is traceability quality, checking whether outputs cite correct source documents, verifying whether reasoning is explainable and auditable. And the last one is the efficiency metrics, time saved in RE tasks, reduction in manual review effort. And overall, RAG makes LLM outputs more reliable, transparent, and aligned with real project data, which is essential for professional and safety critical RE practices. Okay.
First of all, thank you, Lee, for explaining us the architecture and the implementation of RAG in RE. So, while RAG significantly improves the reliability of LLM-assisted requirement engineering, several open challenges remain the same. First, requirement-aware chunking is still unsolved, RE needs chunking that respects requirement boundaries, rational and structure. Secondly, evolving requirements and versioning present issues. Because retrieval system must avoid surfacing outdated documents and support increment reindexing. Another limitations is that multi-document reasoning. RAG can retrieve relevant items, but reasoning across multiple interdependent requirements remains difficult. We also lack RE-specific benchmarks, which makes it hard to evaluate RAG system rigorously. On the practical side, latency and tool integration matter. Retrieval plus LLM pipelines add delay and must integrate cleanly with tools like DORS, Jira, and Polarization. And finally, privacy and security are critical since requirement documents often contain sensitive algorithms. So here is the presentation of our PPT.